preparing standard solutions, but we're going to look at preparing a standard solution from something that we prepared yesterday, okay, which is, once again, these concentrations over here. The concentration of a standard solution can be decreased. So we could make something weaker if we add water to it. Water increases the volume, so you have more water, okay, and the moles don't change, or the amount that we have in there doesn't change, okay. We still had 1.50 grams of copper 2 sulfate pentahydrate from yesterday. We still have that in there today, okay, so we don't change that, but we could add water to make it weaker, okay, just like when you have coffee, for example, in the morning, and if it's too strong, you can always add water to it, hot water to it usually, and make it weaker, okay. You can't do the opposite, of course. If you have weak coffee and you want strong coffee, well, then you got to make new coffee, right? And that's the same thing with solutions, all right? So we're just talking about making it weaker today, diluting it, okay? Dilution is the addition of pure solvent to a solution in order to decrease its concentration. If pure water is used, the overall volume of the solution increases, but it doesn't affect how much solid is in there. So yesterday, we measured out 1.50 grams of solid, put it into here, filled it up to the calibration line, made this standard solution. If we add water to here, we're not changing the 1.50 grams in here, right? That's still the same. We're just making more water in there, right? Putting more water in, so we're making it weaker, all right? So that's kind of what we're going to look at today. And we're going to do this to give you a quick little example here. So let's copy this down here. We have, let's say we have two beakers. So we start out with this one here, and I want to end up with this one here. Okay? In this one here, I have 0.10 molar solution, and apparently I have 250 milliliters of it, so 0.250 liters. And if I do the math on that, I could probably figure out N there, right? You can talk about C equals N over V, or in this case, N equals C times V. So multiplying those two, you get 0.0250 moles. Okay? So that's how much solid I would have, or solute I would have in this particular beaker. Now, if I take this beaker, okay, and I add water to it, to get a final volume of 1,000 milliliters, is what this question says, or a liter, basically, same thing. Okay. How does the concentration change? Well, obviously, it should go down. One of the things I want you to understand here is this, and I've said this a few times, and maybe you understand this, but when you think about this, if I had 0.025 moles of solid here, and I add water to it, so I add water to this beaker here, how many moles do I have here of solid? Yeah, the same, right? I'm not adding any solid to this, I'm adding water, V, all right? So technically, I'd have 0.0250 moles here, okay, as well. And once again, you can talk about C equals N over V here, or N equals C times V here. C equals N over V, so 0.0250 divided by 1 is 0.0250 moles per liter. So that would be my new concentration. And I'll throw in a few other things here that I want you to kind of look at here. By the way, if I started with 250 and then I ended up with 1,000, I think I've added what? 750 here? 750 milliliters is how much water I've added in this case. Okay? All right? So, a couple things that we need to understand here. First of all, this. Okay, look. This comes to good old-fashioned math, and maybe this will confuse you more than it needs to, but look, guys, if N equals C times V and N equals C times V, if the N's are the same, right, because the amount doesn't change, if the N's are the same, doesn't that mean that CV has to equal CV? True? You know, if you want to put this in terms of, like, you remember the math questions, A equals B, and if A equals C, then doesn't B have to equal C? True? Right? So doesn't CV have to equal CV? In other words, and the answer is, well, yes, it does. Okay, and you might say, well, duh, they're the same things. But remember, you're starting with a specific concentration and volume, and you're ending up with a different concentration and volume. But the amount in both of those has to be the same still. So we denote that with little 1s here and little 2s, okay? Just to say, hey, this is the beginning concentration volume. What's my final concentration volume going to be, all right? And by the way, this is the formula you see on the back of the periodic table that I've given to you as always. But also, when you get to university or somewhere down the road, okay, I don't even know about next year, but sometime down the road, you may actually see that as well. And that's the same thing. Initial, initial, final, final. That's all, okay? So there's different ways of representing that, but basically it's just dilution, okay? And I think you guys have that actually on your sheet there for yourselves. All right, so because the amount's staying the same, we can compare the beginning concentration volume to the end concentration volume, okay? Let's look at a few questions here. So there's that stuff there, basically. Let's look at this one here. At least add 75 milliliters of water to 12.5 milliliters of 0.905 molar sodium chloride. Calculate the resulting concentration. So we know that this is going to be a dilution. How do you know that? Well, look. You're only given this one concentration here, okay? And we're told how much we have of it to start with. And then it says we're going to add water to it. So what are you doing? You're making it weaker, right? So look, 0.905 would go here. I'm not going to solve for, if you guys want to, you can. But you're looking for C2, by the way. So if you want to look for C2, it's really that formula there, yes. I'm just going to put the numbers in. Hopefully that's okay for you guys. If you want to do that, that's fine. Okay. You're going to start with a 0.905 molar and 12.5 milliliters of that. Now, she's going to add 75 milliliters to that. Okay. So 25 milliliters, or sorry, 75 milliliters to what she's already has. Okay. At least add 75 to 12.5 with a concentration of 0.905. What's the resulting concentration? C2. What's the resulting concentration? The question is this. Okay, listen. This formula only does beginning concentration, beginning volume, and final concentration, final volume. Okay? So if she's got 12.5 already and she adds 75, we need to put into here 87.5. Okay? 12.5 plus the 75, 87.5. That has to be the final volume. Okay? That's important for these questions. Add 75. Okay? Now listen, this is a rare question. You don't get many like this where she's adding or they're adding water. All right? Usually they tell you the beginning and the final, and that's it, and you just plug the numbers in. Okay? So usually this plus 75 thing here is not part of the question. Usually the question would say it's 12.5 and they end up at 87.5, and they'll tell you those two volumes. So you don't have to worry about adding them. But just make sure it's beginning and end. Okay? And you solve for C2 here. So 0.905, of course, right, times 12.5. You might say, some of you guys are probably saying as well, do I need to change this to liters? Should this volume be in liters? And the answer is no, it doesn't have to be in this formula, because this is kind of like your P1V1 equals P2V2. As long as they match up, right, then you're okay. This is not a specific formula. This is a comparison, right, beginning to end. So as long as your units are the same, that's all that matters. So if you want, you can change them both to liters, absolutely. If you want to keep everything in liters, that's fine. Okay? But just know that they have to be the same. Okay? When you solve for this here, I believe you get 0.129 moles per liter. Is that right? Somebody? Yeah? I think so. We'll go with that. When you multiply those two and divide, somebody will check for me. Yeah? Okay. 0.129. 3 significant digits in all those, so we should have 3 down there too. Okay? So that's an example of the first one there that you would have. Okay? like I said, not the most common type of question. Usually you got the beginning volume and end volume, and you're fine. Okay. We're going to skip this for today. We'll come back to that probably tomorrow. So we're going to go to stock solutions. I'm going to talk a little bit about this. Stock solutions. This definition is a little bit goofy, I guess you could say. But a stock solution is any standard solution that is diluted to prepare a new standard solution. Okay. When you dilute a stock solution, you must calculate the volume of the stock solution as required. This volume is measured out with a pipette. The standard solution will be prepared in a volumetric flask again today, and then we got this example here. Okay, so let me refer to what a stock solution is here. Yesterday, okay, we made this solution here. Okay, this solution, if you remember, was 0.0601 molar copper 2 sulfate pentahydrate. Yes. Okay, you can look up the concentration. We'll use that again today. But this is what we made yesterday. This was a standard solution. We prepared this. Definition of standard solution is something that we accurately know the concentration of. I accurately know the concentration of this because I made it. Okay, so I made this. We know it's 0.0601 molar. Okay, solution. Last night, okay, think of it as a grocery store kind of thing. You got to stock your shelves at the grocery store. So I made this yesterday. It was a standard solution. Now it's in stock. So now I put it on the shelf, and somebody could come by and buy it if they wanted to. $5. Give me $5 for it. Copper 2 sulfate pentahydrate. Can't go wrong. $5. $4. $4. Okay. But you could come by and pick it up off the cart now. It's in stock. Okay? So just like the cookies at night at No Frills, right? Somebody's got to put them on in stock. Someone has to stock the shelves with that. So they're on there now, and now we can use it. So the standard solution has become a stock solution. Okay? It's in stock now. So I'm going to take this stock solution today, I'm going to make a new solution from that called a standard solution, because I'm once again going to know the concentration of that accurately. Okay, so a standard solution can become a stock solution for you to use to make another standard solution. That's all it is. Standard solutions and stock solutions are basically the same thing. Okay, let's take a look at this one here. Notice the first word, describe. Describe. 4 steps probably I'm going to need for this one again. Describe how to prepare a 0.10 molar solution of acetic acid by diluting 17.6 molar solution. Well, keywords, dilution. Yeah? Okay. 17.6 molar. And I'm going to dilute it down to 0.10 molar. Okay, and we'll just take a little break here. So we're starting with 17.6 and 0.10. Hey, look. When you're given two numbers like this, where does the 17.6 have to go? First one or second one? Obviously, the bigger number has to go first. Yes? You can't start with 0.10, add water, and get 17.6. Okay? If you can, let me know, because that's a magic trick that I'd like to know. Okay? You have to start with the bigger concentration, always has to go first when you're talking about a dilution. You're taking something stronger, right? Something that's stronger and making it weaker. So big, small. Yes? How do you make it weaker? You add water. So when you look at V1 and V2, which one has to be bigger? Yeah, V2 has to be bigger number than V1 because you're adding water, you're adding volume. Okay? Always. Always. Okay? So bigger concentration, smaller concentration. Smaller volume, bigger volume. Okay? Has to be. Now, This is all I'm told in the question. So, what am I missing? Can I do this question right now? Obviously not. Okay, and once again, if you can, let me know, because I'd like to know how. You can't do this question at this current time. We're missing something, obviously. What are we missing? Oh, come on. What are we missing? Something. You don't have to tell me where it goes. Just tell me what number are we missing. We're missing a volume. Somebody tell me. Somebody. Say it. Well, I don't know. No, what's the number we're missing? Yeah, 100 milliliters. Look, it doesn't tell us, so we have to assume we're making 100 milliliters, right? Now, here's the tricky part. So, once again, we don't know, we assume 100. Where does it go, is the question. Well, you got two options. You got a 50-50 chance. Okay, I'm not going to let you guess because I don't want you to guess wrong, basically, and I don't want to get that in your head. I will tell you that the 100 milliliters always goes, if you're making a standard solution, it always goes here. You are trying to make a standard solution. Listen. Standard solutions are made in volumetric flasks. So when I am done, I want this to be my standard solution. Okay? Standard solutions accurately know the concentration. How do I know that? Because I made it in a volumetric flask. I need to end up with 100 milliliters of solution. Okay? That needs to go there. And what you are going to solve is V1 here. Okay? So you're going to multiply 0.10 and 100, gives you 10, of course, divided by 17.6, and I believe you get 0.57 milliliters, if I'm not mistaken. Okay? Yes? True? I think so. Okay? It says describe. So here's where the steps are a little bit different. You're not going to weigh out this. You're not going to pour it out onto the scale and weigh it out. Well, first of all, that's silly. You'd never do that. You're not going to pour it into a beaker and weigh it out. This is a solution. We don't weigh solutions. I mean, you can, but we don't weigh it out. We're talking about volumes here. We need to measure that out. So how are you going to measure out 0.57 milliliters? You're going to do something called pipette out. 0.57 milliliters of 17.4 molar. I guess in this case, acetic acid. Okay, that's what the question says. We're using acetic acid here. I want to see the word pipette. Okay, in this case, 0.57 milliliters, so you need to be specific on the volume. And of course, which one are we taking? We're taking the 17.4 molar acetic acid. Okay, now I know some of this is not going to make sense to you until we do the demonstration, so you're going to have to be a little bit patient. Acetic acid. Okay. So pipette out 0.57 milliliters of 17.4 molar acetic acid. Okay? Step 1. 2, you don't have to dissolve it today because it's already in a solution. So you just simply need to place that into 100 milliliter volumetric flask. Okay? Once again, I want to see the words volumetric flask, of course, and you have to tell me the size of it. Okay? We assume it's 100? Sure. Could we make more? We could make 250, we could make 500, we could make 1,000, we could make more of it. Okay? So, it just depends. 3. This is going to be the same as last day. Fill to the calibration line. I guess I should say yesterday. Calibration line with distilled water. Okay, that'll be the same, and 4 will be the same as well. So 3, we're going to fill to the calibration line with distilled water. 3, mix well. 4, mix well. Okay? I know what you're thinking. Hey, I get to see Mr. Bachek do a rubato dance again today. That'll be fun. Hey, you're right. Yeah, we're going to mix it. Shake it up. Ooh, ooh. Shake it up. The cars, you guys wouldn't know them. You're too young. The cars. Okay? So, what does that look like? What is a pipette? What's all the other things I need to use with this? Well, we're going to show you that right now here. Okay? So, special sheet here. One used yesterday, or another one somewhere close to that, whatever. Special second one to do here today. Okay? And I'll kind of read through this with you here for a sec. So, okay. Today we're going to look at preparing a standard solution from a stock solution in the lab. Okay. So this would be the second one of your special sheet from yesterday, wherever you have that. If you want to make a new sheet, that's fine, but you can't lose these two. Okay. Please don't. Prepare a standard solution from a stock solution if you're in the lab. Prepare a standard solution from a stock solution in the lab. We're going to use the we're going to use the standard solution, or AKA the stock solution from yesterday that we have here. We're going to use that today, and we're going to make something weaker. Okay? So we're going to use the same concentration we started with yesterday, and that would look something like this here. Okay? So hopefully we got the first part here. Describe how to prepare a 0.00517 molar solution from a 0.0601 molar solution of copper 2 sulfate pentahydrate. Okay. Describe how to prepare a 0.00517 molar solution from a 0.0601 molar solution. That's the one we made yesterday. That's the stronger one, of copper 2 sulfate pentahydrate. Okay. Once again, when you look at this question, you say, okay, I need to dilute it, obviously. Okay. Sometimes it'll say dilution in the question. If that's the case, you know C1V1 equals C2V2, probably good. We need to start with the stronger one, that one we made yesterday, and we're going to make it weaker. So we're going to end up with a 0.00517 molar solution from a 0.0601 molar solution. Okay? And once again, okay, if we're going to do this, we want to end up with 100 milliliters standard solution. So just like before, we want to put the 100 here. Okay? Anytime you are making a standard solution, that number there is going to be something like 50. If you want to make 50 of it, or 100, or 150, or 200, or 250, 500, 1,000, whatever kind of volumetric flask you're using. Okay? And if you don't know, if it doesn't say, we assume 100, and we're going to solve for V1 here. And when you solve for V1, you will get 8.6, yes. And we probably should use significant digits, so I think it's 8.60, if I'm not mistaken, because we do have 3 in the question here. Remember, the zeros on the front don't count, so 3 there, right? So 3, we probably should have 3 as an answer here. Okay? Now, here's where you guys are going to take some notes. Please don't just look at me and be like, yeah, this is, well, not very exciting at all, but don't just look at me, okay? I'm not that cute or anything like that. Take some notes, okay? Make sure, because there's lots of little things here that we need to talk about. First things first, we're not going to use a scale today, obviously. We're not measuring out a solid. We're starting with a solution, okay? Doesn't make sense to measure out a solution, okay? So, we're going to get rid of that. Let's put that down there too. We have our initial solution. You may want to cap it, like for example, this has sat for a while since last night, so you might want to cap it and just kind of give it a little shake here, just to make sure it's kind of all same thing, dispersed. You know, all the particles are kind of been spread throughout, so we're not just getting the top part or anything like that kind of thing. So just shake it up a little bit to start with here, just to make sure you get a good spread of all the molecules. And we need to take out some of that. So basically what we're saying is, if we took 8.60 milliliters of this 0.061 or 0.0601 molar, 8.6 milliliters of this, put it into this, will give us that, okay, is what we're trying to do. How am I going to get 8.6 milliliters? You're going to use something called a pipette. There's two different kinds of pipettes you can use here, okay? Or you have options for two different pipettes, and you will use both of these this year, okay? So this one here has a big 10 on it, you can see, yeah, and the big bulby part there. And it's got one line on here, right up there. That's the only line it's got on there. So, volumetric flask, yes, only one line on here. What do you think this is called? Volumetric pipette, okay? It only does one volume. That's all it's good for. Is this 10 going to help us with this? 8.6? Not today, okay? This is great. Look at the opening for that. Look how skinny that is. You know what the bubble looks like in there? It's pretty pronounced. You will be able to get a very good 10 milliliters from this. Very good at measuring 10, okay? Because that is so skinny, all right? So very good when we get to that unit, when we get to have to use this, very good at measuring exactly 10. Good, but that's not going to help us for this. This is just a regular pipette. It's measured in milliliters, first of all, always, okay? Yes, I'm sure there's some that are measured in liters somewhere in industries or whatever, but that's not us. This is measured in milliliters, and it's accurate to 0.1 milliliters, so each little tick on here is a 0.1 of a milliliter. So the fact that we're getting 8.6 exactly should be a good chance of us doing that today, okay? The thing with the pipette is kind of goofy, okay? I always joke we got a good deal on these, but how the pipette works is you're going to stick it into the solution, and you're going to suck up the solution from the bottom up, okay? So you don't pour it in through the top, you suck it up from the bottom up, like kind of like a straw. Obviously, don't do that though, eh? Just so you know, before we go any further here, this is how it's labeled on here. Labeled like that. Just think about that for a second. We're sucking it up from the bottom up. So if I go up to 8.6 on this scale here, do I have 8.6 milliliters? No. You actually end up with 1.4. Okay? There's nothing after the 9, so I'm just telling you right now, you can't get less than a milliliter of this solution. It doesn't work. So if you needed a less than a milliliter, you'd have to do something else to get that. You'd probably have to use a smaller pipette, which we don't have any of. Okay? But you'd have to measure that somehow else. Look, if you fill it up to 9, that's really 1 milliliter. If you fill it up to 8, that's 2 milliliters. If you fill it up to 6, that's 4 milliliters. If you fill it up to 0, that's 10 milliliters. Okay? The scale's backwards is my point. So if we need 8.6, what do I fill it up to? It's called a calculator if you can't do that in your head. What do we need to fill it up to actually? 1.4, yes? Those two numbers have to add up to 10, okay? So if I need 8.6, I fill it up to 1.4. If I needed 1.4, I'd fill it up to 8.6, okay? So you got to keep that in mind. This is backwards. Okay? The only one that works out is 5. If you need 5, you get 5. Okay? Other than that, it's the opposite, basically. They have to add up to 10. So, pipette. Now, we're going to need to suck this up somehow. We need to suck the solution up. You know what? Here's the good thing. Be careful if you ever use one of these to get the solution from. Don't ram it in there. Don't let it drop in there, because if you do, this will shoot out the top here because there's not enough space for everything in there. So just do it slowly, okay? And if you just stick it in there slowly, you won't lose any solution, Okay, so we have it in here now, and it's just like McDonald's. You remember McDonald's? You know McDonald's? I hardly ever go there, but if you ever do, or A&W or whatever, or Tim Hortons, you can cover it, plug the straw, and you can pull some stuff out, right? And then you can let it go. Whee! You put it in there again. Whee! And then guys just sit there and do that for about an hour. Eh? And girls are thinking, knucklehead. Eh? Whee! Okay, but we won't do that for an hour. So you can get some solution right away. The problem is I'll tell you right now, that is barely over a milliliter of solution. I need 8.6 milliliters. So that's not even close to how much I need. How am I going to get the rest? Well, don't do this, because if it's acid, it'll probably taste like burning. Okay? We also call that natural selection. Okay? Is the other term I give to those people. Don't do that. Obviously, I'm joking, of course. I've never had anyone do that, but I'm only about halfway through my teaching career, so it still could happen. Let's not be that first person, okay? It could be potentially if it's lead nitrate, it could be bad for you, okay? If it's acid, it's going to taste like burning, okay? It's going to hurt a lot, okay? That's what this is for. This is called a bulb, like a light bulb. It's called a bulb, okay? Most of the bulbs are fine. A couple of them may not work. Just happens, okay? They wear out after a while. There's a little stopper in the bottom part here, okay? Now listen, you can pull that out. Sometimes solution gets caught up in there. So if you overfill it, which is a very good possibility when you first do this, because it's tricky, okay? It's your first time. Has anyone ever used the bulb before? Maybe, okay? So it's tricky. Okay, you might get solution up into here, so if you pull this out and you go like this, you know, like for example, someone already has something in there, who knows what that is. The other thing is too, be careful, we don't know if it could be acid for all I know. It could be a base. It could be water, I don't know, okay? So, if you want to just kind of get some out, we'll know in a minute here once the floor starts, there's a hole in the floor, we'll know it's acid. I'm just kidding, it's not that strong. Okay. It's funny though. And you can just simply plug this back in here, okay? So try not to get it up into here, but you know, in most cases this is going to be your first shot at this, so there is a chance that you might get some in there. If you do, if you're not sure, ask, okay? We need you to be safe, of course. So this is the bulb. This is going to do the sucking for you, okay? And here's my thing here. So really, what I like to do is put this in the weak hand. So weak hand, good hand. This is my, writing hand, stuff like that. Squeeze the bulb. Squeeze it. You're going to put it on top of here, like this. And you're basically just going to let it go. Okay? And as you let it go, solution is going to get sucked up into there. Okay? And you may have to do this numerous times. So you might have to do it once, and then put your thumb on it, hold it there, squeeze it, put it on there again, take your time, let it out, put your thumb on top. Squeeze it, put it on there, put your thumb on top. I'm not getting a whole lot here. Okay, squeeze it, etc., etc. Now remember, you need to get up to 1.4, and there's a few little tricks here I'll show you. Okay, so I have, you always want to go above what you need, of course. Okay, you're not going to get it right on the number 1.4 on the pipette. It's not going to happen. Okay, if you do, buy a lottery ticket. Okay, because that's your lucky day apparently. And then you probably have about as much chance of doing that again as winning the lottery. Now, I'm at above 0 here, so I need to get down to 1.4. If you take your finger off, it drops in a hurry. Okay, look, it drops. Okay, there's 2 milliliters right there. So what you need to do is kind of breathe it, is how I describe it. You kind of breathe your thumb, or you just kind of move it over to the side a little bit, or kind of roll it off a little bit, and you can kind of control how fast it goes, and you just do it really slowly, and you can drop it. Like, I'll show you. There's drops coming out the bottom. I don't know if you guys can see. Drop, 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 drop. We're down to about 1, and then you put a little more pressure on there, you can slow it down. There's 1.4 right there. Okay, and you're going to take that out, and you're going to put it into your new 100 milliliter volumetric flask. Okay, so I'm taking this out, and there is my 8.6 milliliters. Okay, listen, there's going to be a little drop at the end here on this pipette here. That last drop is good. Okay, once that last drop comes out, it usually takes a couple seconds for it to come out. Might even take 5 seconds for it to come out. Once that last drop comes out, that's it. You're done. Do not put this on top and force it through. Okay, so I don't want to see this. Once you got that, people are like, okay, I'm going to let it go, and then I get people that do this and try and get every last drop out of there. Don't do that. It's not meant to do that. It's calibrated so that there's a little bit left. There'll be a little bit of solution left right in here, and it's calibrated like that. You'll never get it all out. Don't force it out. Okay? That's the way it is. All right? So don't put the ball back on top and squeeze it out and think you're going to go faster or something like that. Just let it go. Okay? There'll be a drop at the end. Once the drop goes, you're done. That's it. Okay? What you have now is this. Look, I took 8.6 milliliters of this concentration here, 8.6, and I put it into here. I'm going to fill it up to the calibration line, and I'm going to get that concentration. Okay? And so you would take this off just like we did yesterday. Sorry, you'd fill it up just like yesterday. I'm going to cheat here a little bit. I took the top off here. Fill this up. That's just water, so that should be okay. Fill it up. Remember, you might want to be a little bit short on the calibration line, so that you can mix it up first. So we're a little bit short there. Put the cap on. All right, mix well. Right, lawnmower, etc. Mix it up. Okay, take the cap back off and fill it up to the calibration point, right? And then you're going to have to shake it up again probably just to kind of make sure you get that solution there. Okay, and you'll end up something that looks like this here, of course. All right, so you can clearly see stronger one here, weaker one here. Okay, stronger, weaker. Okay, look stronger, weaker, right? Look. Pretty nice blue color, very light blue, kind of bluish green, right? So that's how you prepare a standard solution, okay? There is a few other things real quick that I'll just mention, okay? That'll be a few little tips for you, but that's kind of what you need to do with that, all right? Listen, there is a couple things that happen here, and this can work to your advantage as well. So if you put it in here like this, and you're going to get your solution, you can do this quite slowly. So you'll notice that the solution comes up very, very slowly. And you can do this over and over again. Oops, that's not good. You can do this over and over again, okay? And take your time really, and do it very slowly. And that's not a bad thing, okay? Taking it really slowly like that. It can help you get very close to where you need to be. If you rest this on the bottom, that's what happens, because the solution has trouble getting into the bottom of the tip because the bottom of the tip is on the bottom of the flask. So it becomes tougher, okay? It's harder to get the solution and it goes a lot slower. If you do this and just lift it up a little bit off the bottom, so if you hold it off the bottom and you do this, it goes a lot quicker. So you need to be paying attention, okay? It goes a lot quicker and it drains a lot quicker. Okay, so it may depend on what you want. Okay, when I do these, I've done a couple in my life, so I tend to do it as quick as possible. I suck it up really fast. But if you want to be very precise for example, and you want to make sure that you don't get the acid in the bulb, you may want to leave it on the bottom and just do little parts at a time, okay? And you may have to do it 10 times to get it up high enough, okay? And that's where your thumb comes in handy too. You have to have your thumb handy. You're not going to do this. I've seen people try and do this, okay? And then sometimes they try and hold like the right amount of solution somewhere with the bulb. That's amazing if you can do that, because I can't, okay? In fact, it turns out usually very badly, all right? So you can't just hold it up with the bulb. You have to put your thumb on top, and you have to seal it in there, okay? And you have to go over and then let your thumb off a little bit at a time to get the right volume that you need, okay? So that's another thing that you need to know, okay? On the bottom, goes really slow. You lift it up a little bit, goes really fast, okay? I don't care. I'm just telling you those are some options, and that really seems to make a big difference. And it's, you know, you want to do it, you know, you want to get good at it, but at the same time, you want to do it so you're not making a huge mess, right? All right, so that's what you need to do for that there. Any questions